Hello. Brilliant. Yeah, hello everyone. I'm Ed. How amazing is this, right? Everyone, oh, wait, I need to mute my mic. Wait a second. Okay. Oh, it's actually on. Can I mute your laptop? Sorry, I've got a bit of echo here. Can you do it? I think I can put that back in, actually. Okay. Everyone can hear me? And hopefully on the stream, people can hear me as well. It's the first ever hybrid event I've run. I mean, to be honest, most people haven't run many hybrid events. A weird time that we're living in. But yeah, it's amazing to have almost a full room in here. And people joining us online as well from around the world, and people in London who couldn't make it in person. Yeah, I mean, good to see we got the first technical glitch out of the way. As I was saying, I'm Ed. I'm the organizer. I work at an ML startup called Selden. I'm the head of developer relations there. And I just, the first thing is just to thank them, right? They have given me loads of time to work on this without making it, a pushy sales project. We just want to keep this as an open community of, interested data scientists and ML engineers in London. And as a company, right, we do, model deployment, monitoring, management, explainability. So if you're interested in any of that stuff, there are a couple of my colleagues around, come find them. But yeah, thanks, right? Because they've also, paid for the food and the drink and, yeah, given me loads of time. In terms of this community itself, right, I mentioned a little bit about it there, but I'd love it just to be a really open forum where, if any of you in the room here today or anyone on the stream has a really interesting story you want to share, hit me up, right? That's the point of this. MLOps is a kind of very poorly defined industry, and it's it's very new, and there's so much we can all learn from each other as we go on our individual or company journeys into that world of production machine learning. So yeah, that's kind of all I wanted to say. Just a quick shout out as well. There's for people, particularly people online, but I guess people in the room too, there's an MLOps community online. It's literally called MLOps community. Well worth joining as well, right? They have great content. They have talks every Wednesday. They have a really good Slack where I get to ask loads of questions and people answer, and it's a bunch of super helpful people on there. So get involved in that too. And then I will stop talking and I will hand over to Tatiana Al-Chueyr. I think I've got that right. Who is a principal data engineer from the BBC. So thank you very much for joining us.
Let's see. Thank you. Yes. Let me share again. Yes. Good evening, everyone. We're about to start. Thank you. Here. Okay. So good evening, everyone. My name is Tatiana. And before anything, I would love to know a bit more about you. So I know QR codes are a bit old school, but if you would like to scan that, or if you would like to just reach out this URL, if the URL or the QR code don't work for any reason, in my Twitter handle, I posted a tweet with a link to this. And the objective with this, there are just 2 questions there. And it's to know a little about you, what you would like to get from this presentation, and which is the stage of MLOps in your company, or how you guys are doing. So it's quite simple. And then the idea is for us to share whatever you reply there. So let's see if this is working. So once you do that, There will be this question. So at what stage of MLOps adoption is your team? And this allows us, both people who are joining remotely, to participate, and who is here as well. And then the other question is, would you expect from this presentation? And of course, I won't be able to change all the slides in real time, but at least I can try to cover some of the things you reply here, hopefully. So this was supposed to be a word cloud. I don't know if that will work. Good, validation. So it's working. So I will leave this open so people can post, reply this. We can have a look throughout the presentation. And please feel free to interrupt at any time, make questions there, just to make this as interactive as possible. So for now, we can see many people are exploring options and use cases. Hopefully we'll be able to see a bit about how we decided doing some things in my team at the BBC. Some are planning to deploy. We have almost 30% who are actively deploying things. And we have some people who have a fully implemented MLOps strategy. Okay, so let's go. That's okay. So my team at the BBC. So the BBC is almost 100 years old, and it's been trying to improve its journey on giving personalized content to the audiences. So as you know, it started as a broadcasting company, TV, radio. Those things can be a bit tricky to personalize, but we are early in the journey. So at the moment, the focus is on personalizing digital platforms like BBC News, iPlayer, BBC Sounds, and those products. And let's see what the future will bring to the BBC. There was also a use case where machine learning was used at the BBC to create some of the content which was published, but unfortunately that doesn't happen as often. My team is Data Lab, and within Data Lab we're a bigger team, and I'm part of a squad who normally has around 3 members. So much of the work I will be presenting here, let's say in average we had 1.5 engineers and 1.5 data scientists throughout a period of 1 year, 1.5 years. And that will give you an idea of what this team of 3 with varying team members was able to deliver. Those are some people who participated directly of the implementation at some point of the project. So I would be talking about one particular recommendation engine family we have. There are other initiatives at the organization. So for a long time in the BBC Sounds app, the BBC outsourced the recommendation engine. So whenever you saw recommended for you, it was a third-party provider, an API where we would forward the requests. And the BBC wanted to own that technology to improve the experience. And my team was targeted with this mission of replacing an external provider, giving better results than them, and proving the BBC could manage its own ML solutions to solve this type of thing. And most of the decisions throughout the organization have been taken data-driven to some extent. So throughout A/B tests, where we would very often compare how editorially curated content compared to recommendation engines, or multiple recommendations engines compared to each other. So our team decided to accept the challenge. Initially, we were 2 data scientists and 1 engineer, and there were lots of questions of how we wanted to implement this. Would we follow a content-based approach, where we would consider only the person we were recommending for you, the person we were recommending things, their own history? Or would we adopt some strategies in collaborative filtering, where we would take into account the consumption of the whole audience of the BBC and learn and try to cluster people based on their experiences? My team initially started with content-based recommendations, and this project we ended up getting a hybrid of both strategies. So we ended up adopting a factorization machine algorithm. The overall idea, we had historical data, which was both program metadata, so episodes, information, genres, master brands, data when it was published, synopsis. We had user activity, what the users consumed, when, for how long. We trained the model, we had model artifacts, and then we would have to predict recommendations with the model, considering only available data. So much of the content we used to train the model was no longer available, but it still allowed us to know the type of things the users enjoyed. And then we would output a set of recommendations, so a group of episodes or specific content. And all started with a prototype. So around 1 to 2 months, the data scientists were very excited. They got lots of Python libraries and started playing with them and tried TensorFlow, LightFM, several options, writing lots of very quick and dirty scripts just to try to prove we could build some model very quickly and something. From their analysis, some models would require more data processing before. Sometimes things would break. Sometimes memory requirements wouldn't be matched. But we had a proof of concept, and the question was, okay, we have this model, and what then? Should we just spend the time to productionize that? How can we validate that? It's not ready for production. We didn't have the data pipelines to ingest stuff. What next? So just to see if BBC Sounds would be happy with the way we were going, we ran some qualitative experiments where it was very hacky, but it allowed us to collect early feedback. So we built these scripts which would output. Initially, the idea was to build something with HTML and all, but they thought, you will have to host, we will have to authenticate users, we're in very early stage. So we just output to RTF. We would get the user IDs, and we made this. We would compute with our model in our own computers the set of recommendations for our brilliant new model. We checked which would be the recommendations for the external provider. We plotted 2 lists of sets of recommendations, our one, the provider's ones, and people had to say if they preferred A or B. It would be anonymized, so they didn't know where the recs came from. And then based on this, they would say if they thought it was better, worse, and why. And with this very scientific and not very quantitative approach, most of our very tiny group of users apparently liked the model we had just trained, and the stakeholders were convinced with this number that, okay, you're allowed to move forward, let's productionize this. When will it be ready to A/B test? And by the time we were quite clueless, because the way we had downloaded the data, part of the data was in AWS, part was in GCP, and things were not in a good shape. We had to deal with some authentication things. The team was very tiny, but we said, we don't know, we will do our best to get this soon. From this moment, I think it took approximately 1 year and 2 months to get this thing delivered live for the A/B test. And something we didn't know in the beginning of the journey was how much, yes, here in the projection it doesn't look very good, but there would be lots of rectangles covering all this area, and this tiny rectangle with the ML code. And by the time, we didn't really know the dimension of how little we had achieved, but yes, it was just the beginning of the journey. The stack we used, we were in Google Cloud Platform. We were the first team at the BBC to explore Google Cloud. Until then, BBC would have mostly on-prem and AWS servings. We used Python. It was the language our data scientists were familiar with. It was simple enough. For orchestration, we adopted Apache Airflow. For parallel processing, we adopted Apache Beam, since we could use data flow. And Apache Airflow, we use Composer. So where we could, we tried to use Google managed services. Luckily, we didn't adopt by the time Google AI platform, since there it had 3 generations. Now it's AI, Vertex AI, but it's changed a lot since. So if we had probably stick to it, we would have more effort adapting to the evolution of their platform. We ended up using Redis to store the pre-computed recommendations. A bit more about this further on. Kubernetes for running the API, and CPU-intensive tasks, and Terraform. So everything was deployed using infrastructure as a code. This was the overview. So we had 2 data sources, user activity and program metadata, and we used those to train. Another interesting part of the work, which sometimes might not be applicable to all business, is that the BBC has to follow some very strict editorial guidelines. So an example of rules we have to somehow apply in the recommendations in the case of news. Sometimes there are news talking about trials, about people who might have sexually assaulted, or they might be judged if they are or not responsible for some specific crime. And this type of content is very sensitive. And let's say the trial will happen tomorrow. The BBC can be held accountable for the trial outcome depending on which news we publish on the previous days. So there are several situations when we do need some sort of business rules. For BBC Sounds, it wasn't as sensitive, but we do need to have some sort of, let's say, scripts which will filter out some content depending on the context of the product. For Sounds, these rules were relatively simple, related to recency, availability, exclude some content which, some master brands which might not be suitable for BBC Sounds, and some other examples. So if we trained the model and we pre-computed the recs on Monday, but the user watched some new content on Wednesday, we want to filter out things they just watched. If a user is listening to some podcast and it's in episode 7, we shouldn't be recommending probably some podcast, some previous episodes. So there are some of these rules which end up becoming a sort of second engine on top of any engine we have, and we have to maintain, and they affect the results of anything we will be recommending. In our pipelines, we did try to split which rules would be common to all users and which rules had to be applied after predicting recommendations. So the idea was to try to minimize the processing we would have to spend. Our first strategy, we knew with Python and global interpreter lock and so on, the chances of having an API which would scale predicting recommendations on the fly was very little, but we decided to do the test. So we did compare in the beginning of the project if we were serving the model live, and per HTTP request, we computed the recommendation, applied rules, and returned the response, how that would compare to pre-computing things, storing in Redis, and then serving from Redis. Our target was for each pod in Kubernetes to be able to serve 1,500 requests, with P95 of the requests taking less than 60 milliseconds. These are some of the numbers we got by the time. So as expected, we adopted Scenic, which is an asynchronous Python web framework. When we tried to predict things on the fly, the number of concurrent requests was quite limited by the amount of concurrent workers. So this was 7 workers. We tried to hit it with 50 concurrent requests. So what would happen is that they would sort of kill the CPU the processor would try to process those things in parallel, blocking each of the workers, depending on the available CPU. So we had 7 CPUs. So we were able to have 1 worker per CPU. And many of the requests, given this load, they were not successful because they timed out. We set the timeout to 1 second in this load test. And these are the times we were talking about when serving on the fly. So obviously, the model we chose, LightFM, the fact we were not batch predicting, serving on the fly, that didn't really meet what we would need to deliver our SLAs. And as opposed to when we had Redis, so since Python was doing a very thin layer, we didn't have, it wasn't bound on CPU, but just I/O on Redis. So the P95 was really 57 milliseconds or even less. So this made us follow an approach of pre-computing recommendations for this particular model. In other models, if you were using TFX or other technologies, you would be able to serve on the fly. But by the time we just assumed the work data science had done, we wanted to see how it would behave in production. So that was the overall strategy. Then we had to choose some orchestration tool. By the time there were a few options, until that point in our team, we had been avoiding to use any orchestration tool. So we would usually have pub/sub, ingest from data sources, have subscribers to pub/sub who would process things, and just try to plug multiple microservices using something in the middle. But we noticed we want to have multiple models, we want to be able to scale, we want to be able to have retries, we want to have visibility of what is going on. And we would like to, using Python, be able to define which steps, when to take them, etc. So we ended up adopting Apache Airflow. One of the reasons was because since we were in GCP, we would have a managed version of it. By the time, there wasn't the Helm chart for Airflow. So we decided we didn't want to have to manage the workflow tooling for what we were building. We wanted to focus on our use case. So this is a bit about the underlying infrastructure on Cloud Composer. It offered a few things for monitoring, which we were able to connect to Stack driver and to notify in the ways we were used to monitoring our applications. One of our mistakes with Airflow was that initially we thought, since it was Python, everything was so niche, we could define custom operators, we thought we could actually run processing tasks within Airflow workers. So we thought everything is Python, we just have to process some millions of documents, locally it works in 1 minute, why not? And that was a huge mistake, particularly considering we were using Airflow running on salary workers, and they didn't really scale. So we had a fixed amount of workers running within Airflow, within Composer. And what happened was, for some more CPU-intensive tasks, our scheduler workers would be blocked by the task we were running. And then the tasks would just pile up, and it would become a huge disaster. So very early in the project, it became very clear we wanted to separate Airflow runtime from any type of task we would run. So we decided then delegating tasks from Airflow to some other platform. So an example, this was the pipeline we built to ingest program metadata, and you can see there were some spikes. So from time to time, there would be a huge amount of episodes and things which had been updated, and sometimes they could take up to 3 hours. And that was just not acceptable for how often we wanted to refresh the content and make the content available to the users. And Airflow, at least the version we were using by the time, didn't have any support for trying to parallelize tasks natively. we would have to build that if we wanted to delegate somewhere else. So that's what we ended up doing. So another thing was, based on the quick and dirty scripts we had written, we were aware of some of the times we would have to spend to pre-compute recommendations for the users. So based on what we had analyzed, if we were running on this type of VM in compute engine, so in the VMs of GCP, it would take 2 hours to predict recommendations for 10K of users. And our plan was to compute recommendations for 5 million of users quite often. So, of course, we could try to parallelize that, but how would we solve this type of issue? So the way we ended up doing was tasks which would scale vertically. So in the case of LightFM, it's a model which you can't really train in a distributed way. We just found ways of having this huge VM with lots of memory where we could train the model and prepare the data for it. So we could use either some compute engine operator, which would spin up a VM and run things there, or a Kubernetes pod operator. We ended up using Kubernetes pod operator, so we would delegate to the cluster, and there we would train. And this was a cluster separate from the Composer GK cluster, so we tried to isolate the runtime. And other tasks, such as pre-computing recommendations, we then wanted some tooling which would allow us to run things in parallel. Within the GCP context, we had the data flow operator and the data proc operator, which would allow us either to use Apache Beam or Spark. We thought, well, in data proc, we would have to spin up a cluster and have some knowledge of Spark. Apache Beam seems so easy. Let's adopt that and see how our data scientists deal with this type of technology. So how many people here are familiar with Apache Beam? Some. And Spark? Wow, many. Okay, so you would probably have taken a different decision. For those who are remote, I would say that 70% of people who are here raised their hands when I asked about Spark. Probably 5% raised their hands on Apache Beam. So Apache Beam is a unified programming model, and it is quite portable, and it has a very interesting design. The idea is that you can write pipelines in multiple languages. You can adopt batch or string processing, and then you can run it in using many types of runners. You could run it on a Spark. You could run in Dataflow. You can run locally using direct runners. So for local testing, it's quite convenient because you don't need to worry about a cluster where to run things. It is quite easy to get started with. This is just the overall idea. You define data sources. You can have transformations. You can output. And it parallelizes the work for you. So you can define, in the case of Dataflow, you can specify how many workers you want. You can tell you just outscale for me. And you can write in Java, Python. Java is probably the most mature SDK, but since we're using Python, we kept it. In the website, there are very simple examples using apples and oranges and things, which make it look very simple. And of course, to go from this to actually running huge volumes of data, pre-computing recommendations, loading a model which is almost 10 gigabytes in memory there is some learning curve, but that's what we did. So this is an example of how some of the program metadata pipelines looked like. In a few minutes or sometimes seconds, we were able to get jobs done for some volumes of data. This is an example of the difference of performance we got from having a Airflow Python operator doing a job to the Dataflow operator. And the 6 minutes, much of it was spin up, running the setup, installing Python dependencies, and tearing down. We could have saved some time there by having custom container images in Dataflow and just loading the container image. And this is the first version of the DAG to pre-compute recommendations for almost 5 million users. So what this pipeline would do was get the model, which let's say was around 8 gigabytes of RAM, get the candidate items were around 200,000 items, and rank those against 4 million users or something. So this is what this Beam pipeline running Dataflow was doing. And once we managed to get this work, one of the concerns was cost. So one run of this pipeline would initially cost us 300 pounds. And then we said, oh my God, what is going to happen now? Am I going to lose my job? What are we going to do? And then, but there was this business concern. We have this external provider. You guys have been working some months on this, come on. And then we just said, okay, so perhaps we can run this very expensive thing less often, just to see how it goes. We will see users might probably hate it because we won't be able to update as often, but let's see how it goes. And that's what we did. So nowadays, this pipeline is much cheaper. Yes, I remain at the BBC, so that's a good sign. And one of the main strategies was we were having the same pipeline to compute predictions and to apply the business rules, and the requirements were quite different. And sometimes, depending on the rules, they would take as much time as the prediction of recommendations, whereas this required quite some memory, this didn't. So we did tons of optimizations there. We used shared memory resources. We used FlexRS to have preemptible instances. We completely refactored this pipeline with aggregated pipelines just to predict things. The other just applies rules. We created some auxiliary data structures to have data pre-formatted in a way that would make the application of the rules more efficient. And yes, so let me see, overall architecture. So this is how this whole project looked like. And the good thing is, from the moment we built this beast, it was quite simple to iterate through it afterwards. So we adopted a configuration-driven approach where we could plug different models and things. And then in our flow, let's say we want to have multiple variants or multiple models. If the first time we built this whole pipelines and things took almost a year, I think in the last quarter, a group of 2 data scientists were able to release, let's say, 5 or more new variants. And we still have lots to improve, but while doing other types of work. So it was relatively successful. Even though initially we would only run this once or twice a week, this increased the user engagement in almost 60%. So our stakeholders were happy. It was completely suboptimal, but they were happy. And particularly with under 35s, which is one of the targets of the BBC, we were able to double the engagement. So sometimes even the solutions which might not be the best, they still allow us to have business gains. So that's what we got. The API latency was within our SLAs. So except some very tiny disruptions, which were under 400 milliseconds, I think our P95 is really, it's really, really little. So the API and the Redis and the serving infrastructure is very lightweight and very cheap. When I look back to this experience we had, since then we learned a lot. We've been doing things a bit different. We implemented other recommendation engines, but I think in the beginning of the project, we had a few options. We could have tried to adopt some cloud built-in proprietary softwares just to speed up the development. By the time, this was quite limited because our data scientists were really keen in the LightFM model. And the AI platform in Google didn't allow custom models. It was quite specific about which models it supported. Then we could have tried to not use Airflow and use a bit of the TFX and try to use other toolings. By the time, they were not necessarily managed. And we just thought, you know what, Composer is there, let's try that. We were not using TensorFlow or Keras, so the integration wouldn't be as smooth anyway. And there is the path where you build custom workflows, train your model, and you do everything, which is quite a painful path, and it took quite long. If we compare the qualitative experiment to actually launching the first version, it was a long way. Other business probably wouldn't have been able to afford that. Many businesses stop in the middle. So this path is the most risky, is the one we took, but it probably doesn't apply in many other projects. And now, let's see how we're in time. We have some time still. So just looking to what you guys said. So this didn't change much from the moment of the beginning. So 40% of the people are exploring options. The decisions we took were one of the options. There are lots of tools. I even asked Ed about Seldon, because it seems to be based on open source, often lots of tools which can help improving this. There are other products out there which could have improved this journey and made it smoother and give results quicker. Some people are planning to deploy. I wonder how you guys will be doing the thing of computing on the fly or pre-computing things. There are trade-offs with each of them. Some people are actively deploying, and others have a fully implemented MLOps strategy. I think we are probably somewhere in between this two, where we are actively deploying, but I do think our team and the BBC as a whole can improve in the overall MLOps strategy. We're in early stages. So about what people expected, new ideas and use cases, how the BBC does ML. We are one of those teams. There are others. I do think Airflow has been a constant. There are other teams which are not necessarily using Python, but I do think most of the teams in the BBC who are developing ML are using Python, at least the ones who build recommendation engines. Cost benefit, this pipeline, which by the time costed $300, we were able to reduce it in some cases to cost less than $1 per run. In other cases, it's still not very cheap. In some cases, it's still the one which has more rules associated, and it's against a huge number of items. It currently costs around £50 per run. But there are some strategies we want to consider. So data flow, it doesn't scale very well on CPU-intensive tasks. So one of the approaches we will be probably trying is to actually have the API serving recommendations on batch mode, which we can host by ourselves or in Vertex AI. And then data flow just does the I/O of sending batches of recommendations to this external service, which will then be pre-computing regs. So we split a bit the responsibility of doing the heavy ML processing. We outsource it, and then the costs will likely reduce. Then another thing, we've also considered just exporting the embeddings from LightFM, for instance, into sparse matrices. And then we can use approximate near neighbors strategies, which are cheaper. So approximations can be cheaper than the exact match. And from our analysis, that will also reduce the expensive part of the pipeline. So it reduces to £1 as well, if not less. Let's see. Education-wise, I don't know. So hopefully with this type of talk, we can share a bit the knowledge we've been having. If anyone has more questions and things, please feel free to just tell me. Yes, so we're open to questions now. Oh no. Come back.
Okay, great. So hopefully you can hear both of our mics now on the stream. Thank you very much, firstly. So can we have a round of applause for Tatiana?
Thank you.
Those on the stream probably won't have heard that, but everyone in the room clapped. Great. We actually had a few questions on the stream, so I'll do those first for people online, and then I'll open it up to the room and people can ask in here. So, right, the first question I had was, have you considered Kubeflow pipelines for ETL?
Yes. So in the beginning of the project, we did consider using those. And we were sort of lazy because we just thought, you know what? We have Composer there. Why should we try to focus on Kubeflow? Some team members felt it was quite strongly opinionated Kubeflow by the time. And so, but I would say and we were very limited on resources, but I would say if you have a bigger team and you can evaluate the tools for your problem, it is probably worth just trying them, right? Having spikes and comparing the tools which are available.
Cool, great. Thank you. And then John has asked, how did your costs, so you talked a bit about the costs already, but how do they compare to your third-party supplier?
They are cheaper. Right now, they're cheaper. When we launched, perhaps they were not cheaper. They were probably very similar, considering the staff, the infrastructure, and all. But now they're cheaper. Yes. We guaranteed our job, I think. Yes.
I think everyone's relieved to hear that you're still at the BBC. So that was a good
Yes, we're saving TV licenses now. Don't worry, guys. We're very cautious with the TV license.
Great. And then did you consider Argo, the scheduler on Kubernetes, to run jobs?
I don't think we did by the time. I would love to learn more about it.
Okay, great. Yeah, there's so many tools out there, right? As you mentioned, it's kind of hard to evaluate everything. And then, this was just a comment, so it's not even a question, but yeah, really good presentation. Thank you for being so transparent about the strategies throughout the path. So thank you for that nice comment. Feel free to leave more nice things in there. Tatiana and I will really appreciate them.
Thank you.
Great, so I'll open it up to the room then here. Does anyone have any questions? Great. What I'll do is I'll bring the mic over and you can say it that way it saves me repeating it on the stream.
It sounds like your team did this a specific way. How reusable has that turned out to be with other teams, and how much sort of cross-pollination between other areas of the business, maybe tackling different problems? Have your lessons learned kind of been applied?
Yeah, so since then, other teams have started using the same strategy. The first implementation of the pipelines wasn't that reusable. The approach was, but the code itself wasn't. So there was quite some work, which one of my colleagues, Darren, focused on for some period of time, which was making sure our workflows were really configuration driven. So both the data sources, the rules, how they were applied, how the steps would connect between each other, how often they would run, which model would be chosen. So all those things at the moment are driven by a JSON. They could be a YAML file. So this allows us to iterate quite quickly. It is still not as quick as we would like, particularly on the model side. At the moment, the workflow, the DAG we implemented, it's quite specific for the technology we built. But that DAG can be replaced by others. So another team ended up replacing it. And one of the approaches we foresee is to really try to adopt a more API-driven approach, because if we just had an API, regardless of the model there, then it could be plugged in any real model and the interface would be the same. So it would simplify a bit the logic which currently lives within the pipeline.
Great. I think we had a couple of other questions. Some people had their hands up. I skipped over them. One here. Brilliant.
Well, firstly, thank you for the presentation. I'm curious about that decision you took about external providers and doing it in-house. Did you set out at the beginning with a plan to eventually bring it in-house, and were there sort of particular reasons for that? And then also, obviously you took the risky bet and it's paid off. What was it about your team that made that possible? Was it because they all had Python knowledge or the way they worked together? Was there anything specific to the team you had?
Yes, so the external provider beach, we're living in a period of time where machine learning is a buzzword everywhere, right? And I think BBC is aware that unless it innovates and finds new ways of delivering its content, and ML is one of the tools to achieve that, it might not have a long lifespan. So it has to iterate, it has to be quick, and it has to prove to be more meaningful, particularly for under 35s. Otherwise, it will cease sooner than later. And to have the knowledge behind and the power of deciding how to implement models and be able to quickly iterate and adopt throughout those things. Before, it was really hard to request changes to the external provider, and it just seemed to make sense for the BBC to have the knowledge and to be able to iterate quicker. Initially, of course, it didn't iterate that quick, but the lessons learned allowed us to iterate faster and faster and have many more models than in the beginning. So from a business perspective, it does feel it paid off. As part of this project, there was a huge work on having a unified recommendations chassis where any part of the organization can build their own engines as long as they respect some API contracts. So there was a sort of unification process and democratization of ML within the organization. So it helped BBC be more mature technology, not as mature as it could, but it is improving. And related to what allowed the team to achieve this, I think it was sort of persistence. So the team was far from being an expert team, okay? One of the data scientists has less than 1 year of experience overall in the industry. The other was quite academic, had mostly done R&D things. And I myself, although I've been in the software engineering area for almost 20 years, my experience with ML was extremely limited, really, really limited, particularly productionizing. So I think the fact we felt the organization supported us in the path we were taking. People respected, and we stick to the plan. So we reduced the scope several moments. So the initial plan was, let's have this recommendations pre-computed 3 times a day, every day, so we reduced the scope completely, and that was okay. So the product was understanding of our cuts and even proposed some of the cuts. And we tried to have that end-to-end, which it's not something we were extremely proud from a technical perspective, right? It's not the thing you would show in an interview and say, look, this is my work. But it matched the business goal. So I think sometimes we set our expectations too high, and those things might work. Another thing I think helped was that before this project, we delivered a recommendation engine using Elasticsearch in, I don't know, a very few months, I think 5 months. And that was the first project the team delivered, and it helped us getting some trust. So we completely simplified. We didn't use proper ML. We used Elasticsearch more like this approach. It was quite naive. It didn't perform as well, but we had something. So sometimes just to get something out of the door, it could be a random recommendation engine or anything, but to have some sort of baseline where people say, oh, you can deliver something in production, it's up and running, it's not breaking all the time. So you gain the trust, and then you can try to use a bit more complex things. You can attempt some tools. And yes, I'm sure there are more successful journeys than ours, but at least we survived, I think, and hopefully it will improve and evolve. Thank you.
Great, thank you very much. I think we have time for one more question if anyone has one in the audience. Brilliant, yeah, go for it.
Thanks so much for the presentation. Did you also try any kind of lightweight GPUs as workers, for beam workers, to improve the performance?
Sorry, could you?
Does it work? Lightweight GPUs as beam workers, but you didn't mention any.
This particular model didn't support GPUs. So it was extremely unfortunate because what happened was, while we were setting on the infrastructure for Composer using Terraform, blah, 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 the data scientists did the analysis of their model, the model. And this was a mistake, okay? Because their criteria of what was a good model from a data engineering perspective or ML engineering perspective would be necessarily a good model. So this LightFM thing, it is a very simple approach. It doesn't support GPU. You can't really parallelize. But they worked on that for 2 months. And they analyzed and they compared with a few things, and they had lots of hassles. And then we just thought, you know what? I would just give some love to my data science, support them in this decision. If we can make things work for this model, then we can try others, which will allow us to use GPUs, which will allow to parallelize. Perhaps that was a silly decision. Perhaps by that time, if we had adopted another technology which allowed us to distribute things better, the cost would have been cheaper since the beginning. I don't know. But from a team culture perspective, I think it helped giving strength and allowing us to trust each other and move forward.
Great, thank you so much. And yeah, thanks again to Tatiana for that fantastic talk. So for everyone on the stream, I guess actually this applies to people in the room too. We're going to take a quick sort of 5-minute break. If people need the loos, by the way, they're right at the back. There's a door there, and there are a bunch of them in there. But grab another drink and then don't go anywhere, because we've got a fantastic talk from Constantinos from BenevolentAI coming up on end-to-end MLOps. Hello. Hey, everyone. Right, we're going to get started again. So if you could just quietly take your seats, that'd be amazing. Brilliant. Okay, so yeah, firstly, thanks again, Tatiana, for that fantastic talk. I know lots of people have been coming up to ask her questions in person. One thing I forgot to mention earlier as well, I talked about my company, Selden, who what we do, and thank them for sponsoring us, but we're actually hiring as well. So, we have roles across engineering in the business. So, please come and talk to me afterwards if you're interested. And without further ado, what I'll do is pass over to Constantinos Neophytou. There we go. I practiced it, still got it wrong, but I'll let him introduce himself instead.
Hi, is this working all right? All right. So can you hear me, everyone? Yeah, excellent. Thank you. Hi, thank you for having me. My name is Constantinos Neophytou. I'm the VP of Engineering for BenevolentAI. And today I'll be talking to you about how Benevolent moved to a centralized ML infrastructure. And some of the lessons we learned along the way, and how we went about doing it. First, a little bit of a background about Benevolent. We were founded in 2014. We have offices in London, New York, and a fully equipped drug development laboratory in Cambridge. It's a highly experienced team. There's more than 300 scientists and technologists, lots of PhDs, lots of publications and patents. Very, very specialized in this area. We provide end-to-end AI-enabled drug discovery capabilities, from target identification to early discovery through clinical development, in-house laboratories for molecular biology, in vivo pharmacology, in medicinal chemistry. We have an integrated knowledge graph, which has leverages multiple diverse data sources, and it's fairly therapeutic area and data modality agnostic. Like we don't pre-train the graph on a specific subset of everything. We just consumes everything, and then we use that to sort of surface what we need. And we have also bespoke collaboration environments for integrated drug development with various partners, as you've probably seen in the media. Our teams are sort of multidisciplinary, cross-functional groups, a mix of software engineers, AI scientists, informatics, machine learning engineers, data scientists, drug discovery representatives, all types of backgrounds. A little bit about myself. I've only been at Benevolent for just over a year. I joined last July. I'm currently leading a few roles, software engineering, site reliability engineering, security engineering, UX design and research, and IT support as well. And I'm also directly managing sort of the apps and infrastructure tribe, what we call, who are responsible for all the front-end and back-end applications for drug discovery, shared engineering, such as common infrastructure, including ML infra, all of our cloud infrastructure on the low level, as well as security and other things. Before joining Benevolent, I worked for 8 years at Google as a site reliability engineer, and then an SRE manager. And before that, a stint as a software engineer at Bloomberg and Morgan Stanley. Now, if I take you back a couple of years in Benevolent, around 2019, we were about 90 employees in product and tech, which is the technological section of the company, not the drug discovery, as opposed to the drug discovery side. We're split in 4 tribes. Each tribe had a squad, each squad 5 to 10 teams. So you can think about maybe a dozen or so teams across product and tech. Each team comprised, as I mentioned, depending on the team, from a variety of backgrounds, a few software engineers, ML engineers, AI scientists, data scientists, informaticians, etc., depending on the squad. Each squad was individually responsible for their own AI development. So I think you can see where this is going. There was some natural alignment between within tribes and between tribes within, between the squads within a tribe. Very, very little to non-existent alignment across tribes. There were multiple standards followed the company for ML infrastructure. Some squads use kubectl with PyTorch, or Spark with PyTorch, or Polyaxon, or I don't think we ever finished cataloging everything. But the point is, it was highly fragmented. Each team was doing what was working for them, and that was fine for a brief period, as long as they were small and doing their own thing. We also had ML pipelines running directly on laptops. The problems became obvious, right? There was no sharing of good best practices. We were starting to lose more and more work into duplicated efforts. Very low BAS factor. Like if someone highly specialized ML pipeline, only 1 or 2 people would know how to actually set it up and run it. Losing one person going on vacation or anything like that would mean that we were effectively not able to run those effectively. As the team size grew, people were naturally moving between tribes and squads. It became a lot more painful to onboard people into new stacks. And a lot of loss of time and inflated costs, because when you only have 1 or 2 engineers working on a particular stack, as Tatiana demonstrated earlier, it can take a long time to get to the point where you can start optimizing. And if you're in an area where these models keep changing and keep evolving, and like new things keep coming in, you may never get a chance to get there. There were a lot of infrastructure failures, a lot of time lost in sort of managing outages and trying to correct data and rerun training. And we never had time to actually get to building tooling for everyone, right? It was quite complicated. And of course, data security and control concerns, like if everyone is doing their own thing, how can we validate and audit that all things are working properly and correctly? So around end of 2019, building a case for MLOps, or how we learned to stop worrying and love the MLOps. The approach that we took was fairly business-centric, and with the goal of unifying an organization that was this fragmented in a way that would allow them to continue delivering without interruption to their teams and their partners. Meaning, yes, we had 90 or so people, but how much of that time could actually be devoted to building these tools? We had to find someone who would campaign this maturity work, right? Both upper management and to the other teams. We'd start by outlining the business needs to the business, defining the cost savings, security improvements, reliability, repeatability of the experiments, and provide just a general overall better experience for the employees, including faster onboardings and things like that. So that's effectively managing upwards. Also, share a structure plan and get a buying among the impacted teams, so manage downwards as well. Like make sure that the individual teams know what you're trying to do and why. Otherwise, it becomes more of a sort of turf grab of like, oh, why are you trying to take over my work? Or why do we need to sort of throw away everything we've done and start over? The benefits to the team may not be immediately obvious. It may be a little bit of extra work at the beginning for no immediate direct benefit to them, but the benefit is to the organization as a whole, right? And to get there, it is important to sort of run it like a serious business project. Like it is an actual effort with its own timelines and its own deliverables, its own metrics. You have to manage stakeholder expectations. You have to define your roadmap, have clear deliverables, clear expectations, and where you aim to be at your path in each time. And then continuous iteration, right? This goes back to proper standard software development practices. Launch early, launch often, iterate, and continue. The last bit about addressing the biggest business need first, not necessarily the coolest, can be a challenge, right? Because engineers have a tendency, speaking from experience, personal experience, not that I've seen. I'm guilty of that as well. It's important to unlock the largest adoption first, right? Get as like the 80% out of the way so that way you can prove that this can actually work. Bring the biggest impact as early as soon as possible, actually deliver something concrete that works. And then you can build on top of it and offer more features, and that's where the benefit to the teams will start showing, right? When they start getting features for free without them having to do any additional work. And also cloud abstractions will allow more people to run ML things that they may not have been able to run at the scales that we can run on a cloud. Not everyone can spin up a Spark cluster by themselves, for example. Our timeline had the idea end of 2019, or slightly before I joined. The project was kicked off beginning of 2020 with the first build launched, which was basically just training on Kubeflow, nothing else, by the middle of the year. We launched a KF serving, including improvements to the API Kubeflow integration, as well as Prometheus and Grafana integration by the end of the year. And beginning of 2021, we basically full on started upgrading features and onboarding more teams. A few of the things that actually were instrumental in rapidly increasing adoption were things like launching managed cloud notebooks, Jupyter notebooks, so that people didn't have to run their own. People didn't have to figure out what to import, what to bring in. We had pre-built images of, like, let's say, recipes of Jupyter notebooks that people could just run. It would connect to the ML infrastructure that we had already set up. It would run and train their models and serve them end to end. We also started launching, we just launched hyperparameter tuning on KTIP and also KF pipelines. For the rest of the year, we're working on onboarding the final remaining teams that are still running their own stacks. I think as of last week, we finally got rid of polyaxon. None of that running anymore. And going into 2022, where the real benefits start showing, right? We expand our capabilities. We start building, I mean, I don't want to promise anything on behalf of the team. We haven't settled on those yet, but for example, things we could deliver, like a feature store, batch processing, anything like that. There are a few lessons that we learned on the way, and the things that sort of could have been blockers, but managed to work through them. First, increasing user adoption. It took a while to get that first team onboarded onto our sort of shared ML infrastructure. If there isn't an immediate benefit, you're effectively asking teams to interrupt their product work to sort of do this little thing that you promise will, like, trust me, it will deliver results sometime down the line. You need to train them, you need to sort of ramp them up onto a new stack, and it can be challenging. The way to address this is, like, have clear acceptance criteria from the beginning, like know what's good enough to deliver to capture the use case of that particular team, and deliver that. Don't try to sort of build the full infrastructure before you start onboarding someone. Otherwise, you're going to run into issues with your reliability. You're going to, like, if the team starts trying to sort of spin up their thing and like a feature is missing or things keep falling down, they're going to get frustrated, roll everything back and run the way things have always run, which works for them, right? The point is we're not trying to do something that works just for one team. We want something that works for every team. Also provide, if you can, provide migration support. Embed, if possible, an engineer from your infrastructure team into the team that you're trying to onboard. Make sure that they're doing work on the product themselves, so they can see in real time what the issues are, that they can provide hands-on support, and actually sort of have a very quick turnaround in sort of debugging and resolving issues, so that you don't spend days or weeks sitting in ticket queues and waiting for things to sort of happen. More advanced solutions, I guess that would be a bit more advanced solution. It requires sort of having that capacity and that time to sort of invest in that. At the same time, when you're planning for one team, don't lock yourself out of the rest of the organization. Like you shouldn't try and paint yourself, like avoid painting yourself into a corner. Make sure that what you're building will actually eventually work for everyone. Even if they don't need it, it won't necessarily block what they're trying to do. So you have to have more or less the user requirements mapped out, but build towards one team first. And as I already highlighted, the benefit of adopting new solution is often observed at the company communal level rather than the individual team. It can be challenging to get that through. Keeping up with the Kubeflow ends. Yeah, what can I say here? Kubeflow changes a lot and breaks a lot in the upgrade process. The ecosystem was quite fragmented up until fairly recently. While upgrades can improve the UX, there are breaking changes that are introduced. It can be difficult to change versions. Like I think upgrading to Istio 1.9 from 1.3 was very error prone, very time consuming. Like I think another example is KF Serving introduced a new API version or something. Like small things like that. To address the fairly standard software development practices around dependencies, organize the structure of the manifest internally, like avoid tools like KF control and use standard like customize and GitOps. I mean, the Kubeflow working group did reorganize the code in a new logical way. We adopted that, made sure that we're sort of following the same practices and making sure that we're on the same page. Some more advanced feature like native AWS solutions like Cognito or group-based authentication instead of user-based authentication to simplify management. Even replace Kube2IAM with AWS. Like there's a few sort of paths to sort of mitigate, but these are problems that you're gonna possibly run into if you're adopting Kubeflow approach, and should probably have a plan to address them as they come up. They're not always gonna be the same problems. And finally, I think it's a question that often comes up. It's how do you pick the right infrastructure? I mean, as many technical decisions, it's a trade-off. You have to do what's right for your organization at the time that you're building this solution. We wanted to pick something that was versatile, generic, well-documented, active community support, so we could actually reach out and not have to build all of the skill sets and expertise in-house. Like we didn't want to build Kubeflow. We wanted to use, right? We didn't want to build our own infrastructure layer. We wanted to have it as a service and offer it to our users. Just understand what your goals and what your needs are. Do you value speed and ease of onboarding versus the ability to change or upgrade? Are you running dozens of models at the same time, which keep changing and have to keep retraining, or do you have a smaller number that you need to keep improving over time? Are you going to be serving to millions of users or to like 3 drug discoverers who are running a target identification system? It varies, right? It depends on what your needs are and what you can achieve. At the end of the day, if you have a dedicated team offering sort of support and an infrastructure service to your organization, yeah, the engineers, the ML engineers working on the systems might be familiar with one type of platform, but at the end of the day, what you can offer as a service to your users and support them in that journey, and in this context, the user is the person working on the models, not the person using the models, is the system you'd be able to most accurately support and provide for, right? More advanced solutions, just figuring out what the costs are, sort of doing a more detailed analysis on like the actual machines that you can get, all that. It depends on your circumstances. And yeah, that was slightly quicker than I thought. It's mostly intended to be sort of a...
Brilliant. Thank you very much, Constantinos. Again, for everyone on the stream, that was a round of applause that you didn't hear. All right, turn that off. 1 second, just sorting the camera out. Okay, Great. We have a question from the stream, so I'll do that one first, and then I'll come back to it if we get any more in a minute. So Maxim asks, have you estimated costs/benefits ratio or other cost metrics from MLOps implementation in your case? So I guess, you talked about use case, the business case earlier. Did you put any costing in that?
There was some cost analysis. The initial goals of the effort were not to reduce costs. So we didn't set out to make things cheaper. We set out to make things unified with the goal that optimizations along the line, as we're able to adopt them, would apply to pretty much everything that we run. So get that, increase the multiplier first, and then start working on the cost optimization side of things.
Okay, great. Thank you very much. I have a question here from Peter. So,
yeah, you didn't mention which cloud providers you ended up using. I mean, I saw AWS in there and Kubeflow, but
yeah, we're on AWS and Kubeflow basically. Amazon Cloud and Kubeflow for pretty much everything. We didn't use any of the AWS native solutions, but that was a team decision. There will be a longer blog post on this on BenevolentAI.com. Yep. And sort of detailing that journey and the actual technical decisions taken. Like I mentioned, I joined sort of halfway through this project and was sort of managing the relationships between the tribes and making sure that everyone was on the same page and working against each other at different points. But this was very much an effort driven by the sort of ML Infra team itself. They were the ones actively engaging with all the squads and all of the engineers who were running these models and trying to get them on board.
are you using a hybrid solution?
We're not.
Sorry, hang on.
So the question was, are we using a hybrid solution? We're not. Just AWS. Yeah, I mean, hybrid solution can solve some problems, but I don't think it solves the problems people think it does. High region availability, and we don't need to, like, if all of Amazon goes down, I don't think us not running our models is the biggest problem we're going to have.
Yeah, I think that's probably fair enough. Yeah, question here.
Thank you very much for the talk. It was great. My questions relate to the adoption process itself. Mm-hmm. So in the beginning of the presentation, you mentioned there are several squads, several tribes. What percentage of those tribes are already using the platform? How is the migration? How have you been able to bring them to the unified platform?
Yeah. I would say about 40 to 50% already using the platform. It's hard to measure because there are quite a few new users on the shared notebooks actively using the infrastructure. They didn't necessarily migrate from somewhere. They just started using this new offering. From the existing teams, I would say about 40%. But like actively working on the remaining thing in parallel. I expect the tail end maybe lasting into next year sometime. But those are very highly specialized cases.
Cool, thank you. Yeah, question at the back there. Go there and come back.
Hey, you talked about the benefits of centralization and unification and standardization, but I'm interested in the trade-offs, the things that you've lost, and the biggest thing that you might sort of wish you'd done differently or sort of lost in that process.
That's a good question. I mean, I don't want to talk for the teams themselves. Obviously, I'm not actively working on these models, so I'm not necessarily engaged into what the problems are. But I do feel that at the end of the day, that those squads and tribes are not in the business of inventing the infrastructure that things should run on. People might have opinions and ideas about how they would like things to run, but as long as you can train your model in a reasonable amount of time and it's available to serve and you can sort of get data out of it, the underlying layer is irrelevant. We're taking away the time that was spent sort of inventing these things and managing these things away and centralizing into one team. Unification and standardization are important. At the same time, so is flexibility. So the biggest part of this effort was figuring out exactly what features we needed to support, right? And then we're going to continue adding it. And at the end of the day, we have, and this only works if you have like a large number of teams actively working on similar problems, right? At the end of the day, once you take away that need to sort of drop down to the infrastructure layer and sort of centralize everyone onto one platform, then any additional feature you add becomes available to everyone at the same time. So there was some rough edges at the beginning where people like lost certain tuning abilities and stuff like that, but they came back. Sort of as they come back, more and more things will become available to everyone. So flexibility is important. You need to know what your users need, but that journey can be difficult.
Great. And then a question from Hamish here.
Sorry, I think it was a bit of a follow-on. It's sort of similar to what you maybe answered, but was there one specific thing that helped the 50% adopt? Like, was there one light bulb moment for them where they saw the value in what you were trying to encourage them towards? And was there one thing that was a sticking point?
So it wasn't necessarily resistance to adoption. It was more of the reverse. Like they were keen to adopt, but they wouldn't necessarily tolerate much disruption to their own processes. Right. So as soon as that became much, they had a couple. We had a couple of attempts, like late 2020, early 2021. They spent maybe a week trying to do certain things, and they're like, "This isn't working. We're going to go back." And back to the drawing board. Go back to what I talked about during the presentation. We just focus on that team, figure out exactly what their needs are, work with them directly, and figure out how that process works. Second time around, take one of our people, put them in that team. Like, go through that process. We did roll back one more time, but then the last time everyone was like, well, okay, I don't necessarily trust that this is going to work because it's already failed twice. I'm going to leave it running for like 2 weeks in staging, see how it works out. No issues, everything ran faster, everything was very, very stable, and they were like happy to just push the button and move it to prod. That was it.
Great. Another question from the audience here.
How do you do cost allocation?
We can do better. There's tagging. We use Cloud Health and tag our resources with namespaces. And projects like different custom tags effectively that allow us to give a breakdown of where the resources are being used. I say we can do better because that doesn't necessarily translate easily into a spreadsheet that then we can show business and be like, this is how much each area, each tribe is spending, or this is how much we're focusing on this sort of drug disease program. But it's, yeah, we do have the numbers. It just takes a bit of work to get to it. But yeah, tagging is the answer, and making sure that the right tags are in the right pods.
Awesome. Yeah, a couple more questions still.
How much of your time was spent on kind of governance and the provenance of the data that's being put through the models versus the infrastructure? Because obviously, you give someone an MLOps environment, particularly the industry you're in, you can't just publish a model every day. You can't just use the data on the output of that. Well, you can publish it, but you can't just necessarily take decisions on that data every day. How much of your remit was around the kind of lineage and provenance, or was it just the infrastructure and enabling the squads?
For this particular team, it was just the infrastructure. Governance and sort of auditing the data, making sure, like figuring out where it came from, what the models came from. They will have a lot of internal tooling that allows that examination. When we train a model, we know which version of the knowledge graph it was trained against and what data went into it. So we can sort of use our internal tooling to trace that back. That's a separate process specific to our use case. Like, I don't think it generalizes very well. I'm always wary of people who attempt to sort of generalize data anything. like data schemas or data access or data other thing. Like it really depends on what data you have and how you use it. So we haven't even tried to approach that, to be honest. At least not from a sort of cross-organizational perspective. Obviously, each team has a solution that works for their data sets. And for now, we're sticking to that.
Great, thank you. I think there was another one over here.
How did the whole transition process disrupt your regular delivery? And were there any particular downfalls before you've noticed the benefits? And how was it managed?
So any particular problems with dependencies?
Yeah, any particular downfalls in the transition process of where you were 2 years ago and where are you now?
So there's a bit of an echo, and I think it's any particular downfalls in
the transition process.
In the which process? Sorry.
In the transition process from where you were to
transition process.
To yeah.
Okay.
Yeah.
I'd have to ask the team exactly what, if anything specific came up. The only thing that sort of surfaced up to me at the time was sort of one was the stability of the actual system at the time that they were trying to migrate. Because obviously the team that's moving on to this new infrastructure needs to be able to convince themselves that the models that they're training and serving actually behave the same way as they expected them to in the old infrastructure. And if you keep having failures, if you have like pipelines that run for like 5 hours or a day or 2 days, and the thing keeps falling down like halfway through, you have no way to validate. So validation was a big part. The other was just the missing feature sets that I mentioned. Snapshotting, I think, was one of them. Checkpointing, being able to sort of stop and resume the pipeline halfway through if you're making changes. But again, those are specific to that team that was being onboarded first. And it goes back to my point about just making sure exactly what the team needs delivered that one thing or that group of features as close to fidelity as possible, and make sure that it can run and stay running enough for them to be able to validate that it makes sense. As far as I don't know exactly if there were any specific roadblocks that the team had while trying to actually build this. They wouldn't necessarily come to me with every problem they had, at least not internally. But yeah, like I said, I think we will, in the next few weeks, publish a blog post about this process, and I'll make sure to ask the team to sort of highlight any pitfalls that they came across. Thank you.
Great, thanks. We have a few more questions in the chat online, so I'm going to go through those, and then I think anyone in the room can come and find Constantinos afterwards and have a chat. From the presentation, you started a very long transition process. Could you solve the same pain points quickly and efficiently by other means? What other options are on the list?
So could have this been done faster with Insight, I guess?
Yeah, I think that's probably what's being asked.
In a smaller organization, probably. As the number of teams grows and you don't have unlimited resources at your capacity, I don't think it's reasonable to expect to be able to move quickly on this. As anyone who's worked in software engineering will probably attest at some point, sort of retooling or rebuilding your infrastructure, especially when you have multiple users, is always going to be a painful process, and some people never get to it. So I think the quickest I've seen was maybe 6 months to have something launched, and then another 1.5 years to like fully transition everything. When you have like 200 teams, it's not a technical problem that can be solved by throwing more resources at it. It's a planning problem, right? You need to get the teams to have the right OKRs, and know that I'm talking about teams that are large enough to require them having OKRs and like deliverables and sort of roadmaps going 6 months, a year, 2 years in advance, and getting that plan fit with those product delivery requirements. It just takes time.
Yeah, good answer. And then Leomarcia, I guess. I don't know if I pronounced that right either. Not doing well today, am I? Did you get support from other engineering teams in the company, or ML team was a bit isolated? I guess they mean the MLOps team, the team building the platform.
So actually the ML Infra team was built out of engineers from across the company. And they obviously had their existing contacts and their relationships with their teams. We had no shortage of requests and insight. We had to limit engagement to sort of the core team with maybe a couple of additional guest contributors. But that wasn't necessarily a hard problem because people had their own work to do. So there was no. Sorry, what was the actual question? Was there any engagement from?
Yeah, did you get support from
support
teams?
Like no one objected to this, right? And people who were interested and had time to contribute did. But it was important to sort of build sort of a cross-area team that had like people from SRE, people from target identification, and a few other like knowledge who understood the problem well enough in a broad enough capacity to actually be able to build this.
Okay, great. I'll do one final question and then we'll wrap up. So what was the turning point to get trust from those data science ML teams using the platform? I think you talked about it a bit, but...
Yeah, so I think stability. Once they saw that they could run their systems with very little effort onto the new platform, everything just sort of fell through. That was for the mostly software engineers and ML engineers on the affected teams. For data scientists and informaticians, I think it was mostly like, here's some free stuff. You don't have to do any work for it. You can just use it around the Jupyter notebooks and sort of managed infrastructure where they just run their business logic. They don't have to care about anything what's underneath, and it just works. So stability, I think, demonstrating that this thing can run and return results.
Perfect. So yeah, thank you again to Constantinos.
All right. Thank you.
Brilliant. So yeah, just to wrap up, obviously a huge thanks to our speakers, Tatiana and Constantinos. For the people in the room, if you want to grab them for a quick chat, I'm sure they'll be obliging unless they need to shoot off. And feel free to stick around for a bit and network. That's kind of the benefit of doing this event, is you get to meet people doing the similar niche job that you do. Yeah, so thank you all for coming. Thank you to everyone on the live stream for engaging and watching as well. And please share feedback. Right, it's the first hybrid event. It's the first MLOps London event. This can only get better and bigger from here. So thank you all.